true inverse function for cosine in numpy? Not arccos. Here is a weird one. I have found myself needing a numpy function that is what I would call the true inverse of np.cos, or another trigonometric function. Cosine is used here for definiteness. What I mean by true inverse is a function in cos, such that for any real float x, two observations, in cos x exists, it is a complex float, and np.arccos x does not do the job, because it only works for -1 is lower than x is lower than 1. My question is if there is an efficient numpy function for this operation or if it can build from existing ones easily? My attempt was to use a combination of np.arccos and np.arccos to build the function by hand. This is based on the observation that np.arccos can deal with x in 1, 1, and np.arccos can deal with x outside 1, 1, if one multiplies by the complex unit. To see that this works, so we could combine this too. This gives the correct results, but naturally raises runtime warnings. I guess since numpy even tells me that my algorithm is not efficient, it is probably not efficient. Is there a better way to do this? For readers who are interested in why this strange function may be useful, the motivation comes from a physics background. In certain theories, one can have vector components that are off-shell, which means that the components might even be longer than the vector. The above function can be useful to nevertheless parametrize things in terms of angles.
My question is if there is an efficient numpy function for this operation or if it can build from existing ones easily? Yes, it is. np.arccos. From the documentation. For real valued input data types, arccos always returns real output. For each value that cannot be expressed as a real number or infinity, it yields nan and sets the invalid floating point error flag. For complex valued input, arccos is a complex analytic function that has branch cuts, inf, -1, and 1, inf, and is continuous from above on the former and from below on the latter. So all we need to do is ensure that the input is a complex number, even if its imaginary part is 0. For an array, we need the appropriate d-type.
If you want to, se aimerait, puis assez John, si subscribing.